Okay, so now we're going to talk about related rates. So whenever you see or the way that you identify a related rates problem is that you're going to see the word rate or increasing or decreasing, something like that with respect to time. So this is when you're going to do the d over dt. So everyone's going to get a d over dt. Things are changing with respect to time. Okay, that's how we would that's how what we would do with these types of problems. So in class, we did a lot of problems with volume, increasing of a sphere. Now we're going to do different types of equations so that you guys can get used to taking the derivative with respect to time. So here we have the surface area of a sphere is increasing at a rate of 96 pi inches squared per minute. Find the rate at which the radius is increasing. So something that I forgot to write down was this. I forgot to give you guys R. So R equals 6 inches. Okay. So the surface area of a sphere is just this. So I gave you the formula as well. Okay. So the formula right now, let's first start off with writing the formula. SA is equal to 4 pi R squared. Okay. Now, the next thing that we want to do, we know that things are changing with respect to time. So I'm going to take a d over dt to both sides because now this is telling me I'm going to change everything with time. Now, the derivative of SA is just going to be 1. SA is just a letter. Okay. It's 1 times the derivative times SA with respect to time. So I'm going to write dSA over dt. Okay. That was ugly. So let me do the eraser. Okay, so this is going to be dSA over dt. Okay, so the change in the surface area divided by time. This is going to be equal to, well, 4 pi is just a number, okay, that I can just take out. D over dt of r squared, so let's take the derivative with respect to time for r squared. That's just going to be 2r, and then I'm going to multiply it by dr over dt. Okay, because now that's what's going to be changing with time as well. Okay, so what are we looking for? Are we looking for dSA over dt, or are we looking for dr over dt? Well, let's look at the problem. The problem says that we want to find the rate at which the radius is increasing. So the rate is this part. So this is what we're looking for. I don't know what this is. Do I know what the rate at which the surface area is increasing? Yes, I do. That's just a 96 pi. So this is going to be, well, 1 times that is just going to be the same thing. So this is going to be 96 pi is equal to 4 pi to, we know what R is. R is that 6 that I gave you times dr over dt. Okay. So I'm going to get 96 pi is equal to, well, 4 times 2 is going to give me 8. 8 times 6 is going to give me 48. Okay, so I'm going to have 48 pi dr over dt. Now all we want to do is just solve for dr over dt. So I can just go ahead and divide by 48 pi to both sides, divide by 48 pi. So this is going to go away. So dr over dt is equal to whatever, well, the pi's also are going to cancel out. So 96 divided by 48, that's just going to give me 2. Okay, so that's going to be 2 inches per minute. So that means that this when the surface area is increasing at a rate of 96 pi, my radius is also increasing at the rate of 2 inches per minute. Okay. All right, so let's do this next problem also. Okay, so we did this one with the surface area. Now we're going to do one with a cylinder. So we have the radius of a cylinder is increasing at a rate of 1 meter per hour. At the height and the height of the cylinder is decreasing. Okay, so notice that decreasing at a rate of 4 meters per hour. At a certain instant, the base radius is 5 meters and the height are 8 meters. Okay, what is the rate of change of the volume of the cylinder at that instant? So we're looking for the rate of change. So that's going to be dV over dt. Okay, that's what we have. All right, so what do they give us? So I don't know what that is. We know that the radius of a cylinder is increasing at a rate of 1 meter per hour. So the radius is increasing. Okay, so that's a rate also. So that's going to be dr, because the radius is r, dr over dt. That's going to be 1. The height of the cylinder is decreasing. Okay, so now the height, dh over dt, is decreasing. So that's going to be minus 4. Okay. at a certain instant, the base radius, so just the base's radius is 5 meters, so just a regular radius is 5 meters, and then the height itself is 8 meters. Okay, what is the rate of change of the volume? Okay, so now if you go ahead and list all of this out, then you should be good. Okay, now I gave you another formula, V equals pi r squared times height. Okay, that's the volume for a cylinder. So I'm gonna have V is equal to pi r squared times height. Okay, now just like we did for the other problem, we're gonna apply a d over dt to both sides. D over dt. So this is just gonna give me dv over dt, because the derivative of v is just 1 times, and we have to multiply by a dv over dt because we know that volume is changing with time. Pi is just a number. And now all I'm really going to take the derivative of is this r squared and h. Now the thing here about this problem is that now we have to use the product rule, okay? Because now we have two different letters. So first, let's take the first one, leave the first one alone, r squared. And now let's take the derivative of h. Now the derivative of h is just going to be 1, but now I'm going to add a dh over dt. Okay? Plus, now the second we're going to leave alone, and now the derivative of r squared, that's just going to be 2r, but now I'm going to add a dr over dt. Okay? All right, and that's it. Now all we got to do is just plug in all of the given answer, given information. So dv over dt is equal to pi. R in this case is equal to 5, so it's going to be 5 squared. The 1 can just go away because anything times 1 is just going to be the same thing. Times dh over dt, that was just equal to -4. Okay, plus h in this case is equal to 8. Then times 2. R was just equal to 5. And then dr over dt is just equal to 1. Okay, and now all I gotta do is just plug all of this into my calculator. So let's see what I get. So I'm gonna get 25 times -4 plus 8 times 2 times 5 times 1. Okay, and what am I get? I got -20 pi. -20 pi. So that means that my volume here is decreasing, okay, at the rate of -20 pi, and then I think this one's going to be meters per hour. Okay. All right, so here are two different types of related rates problems. One of them was much more simpler than the other one, but I mean, these are still really good problems to really work with and try them out. In the next video, I will go ahead and just do this last problem.